Good morning, children. This is Aisha, and let us begin with the first chapter in our chemistry, that is, matter in our surroundings. As we look at our surroundings, we see a large variety of things with different sizes, shapes, and textures. So, all these things that you see around are made up of matter. For example, the pencil, the pen, the book, chair, glass, etc. They are all made up of matter. So, what is matter? We shall be learning about matter in this particular module. In ancient times, according to the ancient Indian philosophers, matter is made from 5 basic elements or constituents which they referred to as tattvas. They are nothing but air, that is Vayu, earth, that is Prithvi, water, that is Jal, fire, that is Agni, and Akash, Nab, nothing but sky. Since early times, human beings have been trying to understand the nature of their surroundings, nothing but matter. There existed 2 schools of thought which had different opinion about the matter. One school believed that matter is in the form of a block, continuous block like that of a wood. Another school thought that matter is something like that of a sand which is not continuous or solid. It's made up of tiny particles. It's the result of their tremendous research and work that we now know what is actually the matter. So here we have some things related to matter that will give a very clear definition to it. A matter is anything that has mass and occupies space. That means it should have some volume and it should have some mass. So a matter is anything that has mass and occupies space, that is volume. And also it should be perceived by our senses. That means it should be felt by our senses. Then only we can consider that as matter. So now we know that matter is actually made up of fine tiny particles. So these particles constitute matter. Under normal conditions, matter exists in 3 states, which is nothing but solids, liquids, and gases. There are 2 other states in different conditions like plasma and Bose-Einstein condensate that we'll be learning in our higher classes. For now, understand that the matter exists in 3 states under normal conditions, that is solids, liquids, and gases. Pertaining to these definitions, let us classify all these things whether they are matter or not. Pen. Yes, it has mass, it has got some volume or it occupies some space and it can be felt by our sense. So pen is matter, book is also a matter, table is also a matter, stone, glass and dust. They all have mass and they occupy some space and can be felt by our senses, and they are like among the 3 states of matter, physical states of matter. Whereas emotions, energy, light, sounds, ideas, thoughts, all these do not have mass, neither do they contain any volume. Do they have any volume? So they cannot be considered as matter. Now let's understand more about the properties of matter. All matter consists of small particles of matter. These particles have some common characteristics and which are laid down in the kinetic theory of matter. This theory gives you a good explanation about the behavior of matter. So it states that all matter comprises of small particles. It is not continuous like wood. Matter is not continuous or solid like wood, but it actually consists of small particles which constitute it. The second one here says that the particles have space between them. The particles are not continuous, but they have space between them. There are some vacant areas between the particles of matter. The third one states that the particles are continuously moving, they are in constant motion. And the fourth one states that the particles attract each other. There is some attractive force within the particles. So let us understand about all these points in detail with some examples. So the first one over here says that all matter comprises of small particles. Let us explain it with the help of one example. You take a beaker and add some water in it, about 100 ml of water. Now to this water, just add a small crystal of potassium permanganate. A small crystal of potassium permanganate in 100 ml of water. You can see that it diffuses and you get a very bright violet color solution, purple colored solution. Now from this, just take 10 ml of this colored solution and pour it in fresh 90 ml of water, clear water. You can still see the color. Now again dilute it by mixing 10 ml of this solution into 90 ml of fresh water. So you go on repeating this dilution until you see a very pale color or until you see no color at all. Despite repeated dilutions, you can still see some color in the 8th or 9th beaker. Just a small crystal of potassium permanganate is able to color a large volume of water, say about 1000 ml. What does this indicate? It indicates that there are so many tiny particles in this small crystal of potassium permanganate which separated off from the crystal, diffused in the solution, and after repeated dilutions they divided and redivided and still could give color in the 8th or 9th beaker. After repeated dilutions also, the particles are there to color the solution in the 8th or 9th beaker. So it is clear, the first point is clear from this, that all matter comprises of very tiny particles. You can carry out the similar experiment with some other solute also. Instead of KMnO4, you can add a different solute like that of copper sulfate, or you can try it with a cap full of Dettol also. Take 100 ml of water, mix a cap full of Dettol and carry on in a similar manner. So you will see and check for yourself until how many dilutions you are able to sense a smell of Dettol. So it indicates that one capful of Dettol contains many particles which divide and redivide and can be felt even after multiple dilutions. So the first point is clear. Let us go towards the second point now. The particles have space between them. These spaces are invisible to our naked eye, but particles of other matter can get between these spaces without increasing its volume. There is a very simple activity that can help understand this point. Take some water in a beaker and mark the level of the water. Now add some salt in it and stir well, mix well. You can see that the salt dissolves completely and there is no change in the level of the water. You can't see any rise in the level of the water. That means the volume did not increase in spite of mixing salt in it. So what does this indicate? It indicates that the particles of matter have got space between them and the salt particles have occupied these spaces, which resulted in no increase in the volume. So the dissolution of salt or sugar in water proves 2 points over here. That is, all matter comprises of small particles and they have got some space between them. Coming to the third point, that is, the particles are continuously moving. The particles present in matter move continuously. They are said to have 3 types of motions. 1. Translatory motion, where the particles move in a straight line or in a curved line in a forward direction or a backward direction and collide with the other particles of matter. The second type of motion is a vibratory motion, where the particles move to and fro. The third type of motion is called as a rotational motion, where the particles move about a fixed axis. But in common, the movements of particles is called as random motion or Brownian motion. It's called as the random motion or Brownian motion. So anything that moves without following a particular pattern or direction is said to have random motion or Brownian motion. So this movement is maximum in gases and least in solids pertaining to their molecular arrangements. So there's one more very important thing that you have to understand here. It's nothing but kinetic energy of these particles. So the velocity of each particle determines its kinetic energy. There is also an exchange or transfer of energy between the particles when they collide between them. So the amount of motion is proportional to the temperature. So there is a direct relationship between the kinetic energy and temperature. So here you can understand that the particles tend to move faster when there is an increase in the temperature. So you can understand now that why the smell of hot sizzling food reaches your nose quickly, more quickly than the smell of cold foods. Did you understand now, children? You can understand this with the help of another example. Try mixing or dissolving sugar in cold water. It's very difficult to dissolve sugar in cold water. If you slightly warm the solution, if you slightly warm the water, the sugar easily gets dissolved. So what do you understand by this? So the sugar, once the temperature is increased, the solubility of the sugar also got increased. That means the particles of the sugar were able to diffuse easily, to move away from each other easily once the temperature was increased. Coming to the fourth point of kinetic theory of matter, the particles tend to attract each other. That means there is some attractive force between the particles of matter. It is maximum in case of solids because the particles are so close to each other, and it is least in a gas because the separation between the particles is very large. They are very far from each other, and so there are no attractive or repulsive forces in a gas. So it's very easy. Now you understand that it's very easy to separate particles of liquids. Try breaking an iron nail. It's very difficult because it's a solid and it's got a lot of strong attractive force between the particles. That's all for today, children. In my next module, I'll be explaining about the different states of matter with respect to different properties and also about their interconversions. Thank you.